Have you ever pondered the future of energy production and what role artificial intelligence might play in it? As we stride forth into the future, our need for energy is only growing. The lights of our cities, the hum of our devices, the roar of our vehicles, all demand power. Yet, we're also increasingly aware of the need for sustainability, for energy sources that won't deplete our planet or pollute our skies. Enter fusion energy, the same process that powers the sun and the stars, now being harnessed on Earth. At the heart of a fusion reactor we find plasma, a superheated gas that fuels the fusion process. When atoms in the plasma collide at high speeds, they fuse together, releasing energy. It's a promising solution, potentially providing vast amounts of clean, efficient energy. But as with all great innovations, there are challenges to overcome. One of these is maintaining stability in the plasma. Output. So, what exactly is plasma and why is it so important in fusion reactors? Well, to start, plasma is often referred to as the fourth state of matter. We're all familiar with the first three states, solids, liquids, and gases. However, plasma is a bit different. When enough energy is supplied to a gas, the atoms become ionized, meaning they lose or gain electrons. This process creates a sea of charged particles, both positively charged ions and negatively charged electrons that move freely. This soup of charged particles is what we call plasma. Now you might be wondering, what's so special about plasma? In the context of fusion reactors, plasma plays a starring role. Fusion reactors aim to replicate the process that powers our sun and stars, which is nuclear fusion. This is where lighter elements combine to form heavier ones, releasing a tremendous amount of energy in the process. And guess what? This process happens in a high-temperature, high-pressure environment where matter exists in the plasma state. Plasma, due to its unique properties, can be confined in a strong magnetic field, allowing us to control it. In a fusion reactor, we create a plasma from hydrogen isotopes and heat it to extreme temperatures. We're talking millions of degrees here. Under these extreme conditions, the hydrogen nuclei overcome their natural repulsion and collide, fusing together to form helium and releasing a massive amount of energy. But creating a plasma and maintaining it under these conditions is no easy task. To be used effectively in a fusion reactor, plasma needs to be kept stable and hot. It needs to be confined in a way that prevents it from touching the reactor walls, which would cool it down and stop the fusion process. As you can see, plasma is an essential component in fusion reactors, but its volatile nature presents a significant challenge: maintaining stability. This is where the next part of our discussion comes in, looking at how we tackle this challenge and the role of artificial intelligence in keeping plasma stable in fusion reactors. But that's a story for another scene. Maintaining plasma stability in a fusion reactor is no easy task. But could artificial intelligence be the answer? You see, traditionally, maintaining plasma stability has been a constant challenge. It's like trying to hold a blob of jelly in your hands without it slipping through your fingers. Human operators constantly monitor and adjust the conditions inside the reactor, but the process is far from perfect. Enter artificial intelligence. Imagine a system that could monitor the plasma in real time, making lightning-fast adjustments to keep it stable. This isn't some far-off dream, it's a reality that scientists are working on right now. With the aid of machine learning algorithms, these systems can learn and adapt, improving their performance over time. This means less time spent manually monitoring the plasma, and more time focusing on improving the efficiency of the reactor. So it seems that artificial intelligence could be a game-changer in the world of fusion energy. As we look to the future of energy production, fusion energy powered by artificial intelligence seems to be a promising prospect. Let's recap what we've learned. Our growing need for sustainable energy sources is undeniable. Fusion energy, with its potential to provide clean, limitless power, stands out in the field of possibilities. At the heart of this technology is plasma, a superheated state of matter that fuels the fusion reaction. But here's the rub: maintaining plasma stability is a Herculean task. It's like trying to hold a sun in a bottle, a challenge that has stumped scientists for decades. Enter artificial intelligence. With its ability to learn, adapt, and make lightning-fast decisions, AI offers a promising solution to the plasma stability problem. By controlling and optimizing the fusion process, AI could unlock the true potential of fusion energy. Indeed, the future of energy production looks bright, with fusion energy and artificial intelligence leading the way.